All right, let's skip the fluff and dive straight into how you can stop losing those crucial, easy marks on the Cambridge Biology 9700 exam. Today's explainer is targeting topic 14.1, the structure of the human kidney. But listen, we aren't just memorizing parts today, we're mastering the elite exam strategy you absolutely need to turn basic knowledge into top band marks. Right out of the gate, picture this terrifying scenario. A student sits down, takes a deep breath, and gets the final calculation absolutely right for a super complex renal physiology question. But when the grades actually come out, they score an absolute 0 on that very question. So how does a perfectly correct answer lead to 0 points? Let's unpack it. Well, this happens because ordinary rote revision completely fails when examiners test your methodology over mere memorization. They don't just want the answer, they want to see your analytical process right there on the page. In Cambridge Biology, that final number is honestly only a fraction of the story. You might have the right answer, but if you leave no trail of evidence, you get 0 credit. It's harsh, but it's the reality. Okay, let's jump into section 1, core kidney structure, the anatomy solution. First things first, we've got to lock down the biological framework you need to actually survive these tricky exam questions. You really can't execute advanced analytical strategies without having a rock-solid grasp of the anatomy of self, right? So we'll break this down step by step, starting from the outside and working our way in. First up is the fibrous capsule, which basically acts as the kidney's essential outer shield. It's this incredibly tough protective membrane that keeps the delicate internal filtering machinery completely safe from physical trauma and infection. Fun fact, your kidneys filter about 45 gallons of blood a day, which is wild considering they're basically the size of a computer mouse, so they absolutely need that tough outer layer. Moving just inside that, we hit the cortex, the crucial outer functional region. As you'll see, this is where complex ultrafiltration actually begins. The cortex is just densely packed with renal corpuscles and those highly convoluted tubules that do the heavy lifting of initially filtering the blood. Now, what's genuinely fascinating here is how the medulla's structural arrangement sets up the exact osmotic gradients required for water reabsorption. It's organized into these really distinctive fan-like renal pyramids, and it houses the vital loops of Henle. Without this specific, highly organized anatomical structure, your body's ability to concentrate urine and conserve water would literally be impossible. And finally, right in the center, we reach the renal pelvis. Think of this as the main funneling point, completing our visual map of the macroscopic anatomy. It collects all that fully processed urine from the medulla and safely channels it right into the ureter to exit the kidney. So you've got the anatomy down, but here is the massive catch. In just a second, I'm going to show you a hidden examiner clue that changes the answer completely. But you really needed that anatomical framework we just covered to make that clue obvious. The anatomy is your foundation, but the strategy, that's how you actually build the house. Which brings us to section 2, the method mark strategy. If you want to transform from a student who simply memorizes biological facts into an absolute elite problem solver, this is the exact procedural framework you must use every single time you tackle complex stimulus materials. Step 1, deconstruct the question. Step 2, extract the critical data from the provided tables or graphs. Step 3, select your analytical framework. Step 4, execute clear notation. And step 5, present your answer using correct terminology. If you follow these 5 steps, your evidence is perfectly laid out for the examiner. Let's actually put this into practice. Pause for a second and predict the error in the flawed statement we're showing here. Saying something like, the cortex filters blood, is fundamentally flawed for an A-level exam, even though, yeah, it's technically true. The improved top-band answer scores so much higher because it seamlessly integrates evidence, correct scientific terminology, and very specific reasoning. By mentioning ultrafiltration driven by high hydrostatic pressure, you're proving to the examiner that you truly understand the underlying physiological mechanism. Moving right along to section 3, top 3 principal examiner warnings. You've got to pay super close attention to these traps, straight from the Cambridge Principal Examiner reports. First, missing units in your calculations will instantly cost you marks, literally instantly. Second, using sloppy anatomical terminology, like casually confusing the cortex with the medulla, ruins your credibility entirely. And third, failing to link your knowledge directly to the provided clinical or experimental context means you aren't actually answering the specific question being asked. I want you to literally memorize this quote. The examiners themselves are practically begging you to show your step-by-step logic to secure those method marks. It is a built-in safety net. If you slip up on a tiny decimal point at the very end, but your process is clearly and logically laid out, you will still get credit for your methodology. All right, Section 4, Critical Analysis and Evaluation. To hit that absolute top mark band, you've got to evaluate investigations using a comparative matrix exactly like this one to systematically break down the experiment. You must identify the limitations by checking for weaknesses in the experimental design. You've got to question the assumptions behind the givens to check data validity. And finally, you must propose alternative interpretations of the data. This structured approach literally forces you to evaluate the evidence comprehensively, exactly like a top-tier student should. So, the big takeaway here is that syllabus topic 14.1 isn't just about coloring in and labeling diagrams of the kidney. Top-performing students exhibit a connected, conceptual understanding that transfers seamlessly to completely unfamiliar datasets. They connect the macroanatomy to the microphysiology, and then they brilliantly apply that to whatever experimental data the exam throws their way. And finally, Section 5, the diagnostic cliffhanger. Before we wrap this explainer up, imagine this absolute nightmare scenario. A student knew the kidney anatomy perfectly. They showed all their working, they applied the critical analysis matrix flawlessly, but they still scored an absolute 0 on their final high-value essay response. How on earth is that possible? Well, because they completely misunderstood the exam's hidden command words. They described when they should have evaluated, or they explained when they should have analyzed. To decode those precise command words that dictate the mark band and solve this mystery, you absolutely need to watch our next explainer right now. Make sure to subscribe to our YouTube channel, AC Exams, to excel in your Cambridge biology papers. Because I want you to ask yourself one final thing. What good is knowing all the right answers if you're answering the wrong question? Click over to the next explainer, and let's master those command words together.